Hey everyone, welcome to another video. In this lesson, we are going to go through disk method around x-axis, y-axis, and other axes. 8.9 is specialized about the x-axis and the y-axis, and 8.10 is about other axes. So what is this lesson about? Every time I'm teaching this lesson, I can't help but remember shawarma, because it's basically taking a function, a 2D function, and rotating it around a certain axis, and then you're gonna get a 3D function, like a 3D solid function. So it reminds me of a shawarma, because if you turn the chicken shawarma around the rod, it literally creates the chicken shawarma. You know what I mean? So if you look at the first function, if you look at the first example, you'll get exactly what I mean over here. This is y is equal to x squared, and if we are rotating it around the y-axis, we're gonna get this solid over here. So as you can see, this is where the analogy of the shawarma came from. So as we are turning the function in this manner, we are creating the solid that we need. So the volume for such solid is represented by, since we're turning it around the x-axis, it's going to be represented by a to b on the y-axis. Let's say it's from here to here. Pi r of y squared dy. Now the reason why we're using pi r squared is because the cross sections that you can see over here, all of them are circles. So the area of each of these circles are going to be represented by pi r squared. And since it's around the y-axis, I need to set my integration up with dy, and I need to set up my radius function with r of y. So what is r of y? R of y is basically the distance from here to here. So since this is y is equal to x squared, it's the same as saying square root of y is equal to x by putting square roots on both sides. So it is going to be the integration from a to b pi, and then the radius is going to be the square root of y minus the y-axis has the function x is equal to 0. So 0 squared dy. Okay, so this is how we use disk method for rotating functions around the y-axis. Now if you look at the second equation, second graph, you got y is equal to the square root of x, and if we're rotating it around the x-axis, we're gonna get a shape that looks like something like this. It's not going to be very accurate. So again, shawarma, same thing. So over here, the radius is going to be projection down because it's with respect to the x-axis. So it's going to be, let's say that this is a to b. So the integration is going to be from a to b pi, and the radius is going to be the square root of x minus, this is y is equal to 0. So square root of x minus 0, all of it to the power of 2 dx. So this is basically how to find the volume of such solids if it's rotating around the x-axis or the y-axis. Now we are going to solve this exercise, solve these two exercises, actually, one for x-axis and one for y-axis, and then finally we're going to do one for the other axis. So in number 2, they told me take the region bounded by y is equal to e to the power of x. So let's draw our shape. So we got x, y. So this is going to be my exponential function. I mean, it's not exactly like that, so do it again. Yeah, this is better. So over here, we know that e to the power of 0 is 1, so this point is 0, 1. And this, all of this function is y is equal to e to the power of x. We got y is equal to 0. Y is equal to 0 is basically the x-axis. and this is supposed to be x is equal to 0, so that's the y-axis, and x is equal to 3, which is a vertical line over here. So the solid, as you can see, is this over here. So they said we need to revolve this region around the x-axis. So if we are revolving it around the x-axis, we're going to create something that looks like this. So it's going to be this shape. Okay, so it looks kind of like a horn, but this is basically the shape that we are looking for. So the volume, let's set up our integration. The volume is going to be from, so since it's rotating around the x-axis, we need to see the bounds on the x values. So we started at x is equal to 0, and we ended up at x is equal to 3. So 0 to 3 pi. Now what's the radius? Projection down. So it touches the y is equal to e to the power of x first, and then it touches the x-axis, which is y is equal to 0. So e to the power of x minus 0 to the power of 2 dx. That is my radius function, which obviously you can see it over here. Okay, so yeah, that's basically just the integration. Okay, so all you need to do over here is plug it in on a graphing calculator and you're good to go. Now, for number 3, they said take the region bounded by y is equal to 4 minus 2x, y is equal to 0, and x is equal to 0. So to draw our coordinate system, x and y. So 4 minus 2x is going to be a straight line with a y-intercept of 4, sorry, with a slope of 2, negative 2. So let's say it's over here, y is equal to 0, x is equal to 0. So the solid that we are finding over here is this triangle. And they want me to rotate it around the y-axis. So when we are rotating it around the y-axis, we are creating, let's say it's like this, and then like this. So we're creating a kind of a cone. If you look at it properly, no, that's not a semicircle or anything. Let me just do one more. Perfect. So over here, since I'm rotating the function around the y-axis, my volume should be according to the y values. So first things first, I know that this value over here is going to be 0. The value on top is 4. So the volume is going to be from 0 to 4 pi. Now what's the radius function? The radius function is basically us moving in this direction. So it touches this function over here, and then it touches the y-axis, which has a function of x is equal to 0. So first things first, since this is y in terms of x, I need to change it into x in terms of y. So y minus 4 is equal to negative 2x. So 2x is equal to 4 minus y. So x is 4 minus y over 2. So this is going to be 4 minus y over 2 minus 0, all of it to the power of 2 dy. 0 to 4 pi 4 minus y over 2 to the power of 2 dy. All right, so in this part, we're going to be finding the volume of solids revolving around lines that are not the x-axis and the y-axis. So in the first question, we got y is equal to 3 minus x squared, then y is equal to 2, and we're going to revolve that around y is equal to 2. So if we are going to draw the functions in themselves, we're going to get a parabola of y-intercept of 3. So let's make a parabola, random one. Okay, so let's say that this point is 3, and then a straight line. And let's say that this is 2, y is equal to 2. So the solid is going to be over here. And if we are revolving this solid around y is equal to 2, so we're revolving around this line over here, it's gonna create this oval shape that you're gonna see over here. So it's gonna go around it. If you can, I'm gonna zoom in a little bit, so it's gonna go around this. Okay, so first things first, the cross sections are circles, obviously. How can we find the radius of these circles? We're gonna do a projection perpendicular to it, because each cross section, I'm gonna zoom in again, each cross section, if it's a circle, then that means it's gonna be a projection from the top function, and then it's gonna touch y is equal to 2. So it's obvious for me that the radius function that I'm gonna do over here, it requires me to do a projection perpendicular to the x-axis, or in this case, it's perpendicular to y is equal to 2, which is a horizontal line, which is parallel to the x-axis. All I'm saying is that in order for me to set up my integration over here, since I'm doing a line perpendicular to the x-axis, I must find the bounds of the integration. And the bounds of the integration should be x values. Now, what are these 2 points that I circled over here? They're basically the intersection points between y is equal to 3 minus x squared and y is equal to 2. So, for this reason, I'm going to set them equal to each other. So, 3 minus x squared equals to 2. Now, take the negative x squared to the other side, take the 2 to the other side. So 3 minus 2 is equal to x squared. So 1 is equal to x squared. So x is going to be plus or minus 1. So at this point, it's minus 1, 2. Over here, it's going to be 1, 2. Okay, so now since I know the bounds of my integration, it's going to be the volume equals the integration from negative 1 to 1 pi. What's the radius function? Projection down, it touches 3 minus x squared first. So it's going to be 3 minus x squared. And then it is going to go down to y is equal to 2. So minus 2 squared dx. So 3 minus 2 is simply going to be 1. So it is going to be volume equals negative 1, 1 pi 1 minus x squared d squared dx. That's it. All right. Now, in some MCQ questions and even FRQ questions, they would give you like an extension of this question, and they would ask you like, what sort of translation can I do over here? And I would still get the same exact volume. Like, all I'm saying is over here is that this integration that we got, the answer that we got, is literally going to be the same exact integration if I translate this function 2 units down. So I decreased y by 2. Okay, so over here, instead of y is equal to 2, it's going to be y is equal to 0. And over here, since it's going to be y is equal to 3 minus x squared, the y-intercept is going to decrease by 2. So it's going to be 1 minus x squared. So if I have a what-if situation, y is equal to 1 minus x squared and y is equal to 0, which is the x-axis in this case, and I'm doing the same exact volume, like I want to find the same exact volume over here, that means the volume is going to be from negative 1 to 1. Since I'm translating it down, the bounds are going to stay the same. So it's going to be negative 1 to 1 pi. Now, the first function, it's going to be 1 minus x squared minus 0 to the power of 2 dx, which is essentially the same. And they should be the same because you're not increasing the volume or you're not decreasing the volume. You're just changing the position of the function. So the volume should stay the same. Again, this question can come in any FRQ or any critical thinking question that is like a follow-up question after you find the volume. Now, in the second situation, I got x is equal to 2 minus y squared, and I got x is equal to 1. So let's draw our coordinate system. We got x is equal to 1, which is, let's say, a line over here. And I got x is equal to 2 minus y squared. X is equal to 2 minus y squared is basically also a parabola, but this parabola is horizontal, pointing to the negative side of the x-axis. So it's going to be something like this. So, wait a minute. Let's do this first. Perfect. And let's say that this is 2. So this is x equals 2 minus y squared. So the solid is right over here. And if I'm going to rotate it around x is equal to 1, see that? Around x is equal to 1, exactly like a shawarma stick, it's gonna look something like this. So more or less, you get the idea. So it's turning around it. Let's zoom in. It's turning around it. So the cross sections are obviously going to be circles. So over here, the radius function is going to be from here to here. So basically, I'm doing a projection perpendicular to a vertical line. So it's similar to a projection perpendicular to the y-axis, which means that my functions need to be in terms of y, and my integration needs to be in terms of dy, and my bounds should be from here to here. So from here to here. So how do we find these 2 points? The intersections between x is equal to 2 minus y squared and x is equal to 1. So the intersection between x is equal to 2 minus y squared and x is equal to 1. So just simply replace x with 1. So I get 1 is equal to 2 minus y squared. Replace the negative y with a 1. So y squared is equal to 2 minus 1. So y squared is equal to 1, which means y is equal to plus or minus 1. So this is 1 minus 1, and this is 1, 1. Now, so the volume is going to be from negative 1 to 1 according to the bounds of y, pi. Now, the radius function is going to be, first of all, it's going to be touching this function over here, which is 2 minus y squared. And then it's going to continue forward, and it's going to touch x is equal to 1, so minus 1, all of it to the power of 2 dy. So over here, 2 minus 1 is going to be 1. So the volume minus 1, 1 pi 1 minus y squared dy. Okay, yeah, that's the question. Now, let's say we're going to do the same exact what if situation in the first process. What if I translate this function? This is 1, so let's say we translate it 1 unit to the left. So we're going to translate it 1 unit left. So all I'm doing over here is basically this is going to be minus 1 and this is going to be minus 1 as well. So the new function I'm going to have is basically 1 minus y squared, and the new line over here is going to be x is equal to 0. So if I'm going to find the volume, it's literally the same exact thing. Now the bounds are not going to change because if I'm shifting to the left, nothing is going to happen vertically. So the volume is going to be from negative 1 to 1 pi, and it's going to touch 1 minus y squared first, minus 0, so it's still going to be 1 minus y squared, all of it squared, dy. Isn't it the same? It's exactly the same as it should be. Alright guys, I think this is enough for this video. If you have any questions, please leave it in the comments. Be sure to watch the next video about Washer's method.